Hi everyone, welcome to Treeker and Academy YouTube channel. Hope you all are doing well. This is Dikshant. I come up with most important MCQs on inverse trigonometric function. These questions are very important for CBSE board exam. This is all about me. Before going to start MCQs question, you should know about domain and range of all inverse trigonometric function. Range sometimes called it as principal value. Now let's move to the first question. Domain of tan inverse x. The domain of tan inverse x is from minus infinity to plus infinity. So correct answer is D. Domain of sine inverse 3x minus 1. Suppose 3x minus 1 is y. Domain of sine inverse y is minus 1 to 1. Put the value of y. We get 3x minus 1 is less than equal to 1. Add plus 1 both side. Become 0 less than equal to 3x less than equal to 2. Divide by 3, it become less than equal to 2 by 3. The final answer is D. In third question, find the domain of sine inverse 3 sine inverse under root x minus 1. Suppose under root x minus 1 as y. Domain of sine inverse y is minus 1 to 1. Put the value of y, it become under root x minus 1 is less than equal to 1. Square root of under root x minus square root of x minus 1 cannot be negative, so it can be write it as 0 less than equal to 1. In next step, squaring both side, it become x minus 1 less than equal to 1 plus 1 both side, become x is less than equal to 2. So correct answer is A, 1 to 2. In fourth question, find the domain of sin x plus sine inverse x. Basically, domain of sin x is all real number. Domain of sin x is all real number, and the domain of sine inverse x is from minus 1 to 1. The domain of overall function is the intersection of both domain. Intersection of both domain become minus 1 to 1. So correct answer is option C. In fifth question, find the domain of sine inverse minus x square. Suppose minus x square as y. Domain of sine inverse y is minus 1 y is to 1. Put the value of y, become minus x square. Because of negative sign, this minus x square can not greater than 0. It means minus 1 is less than equal to x square is always less than 0. After removing minus sign, it become x square is greater than equal to 0. In next step, take square root both side. It become minus 1 less than equal to x less than equal to 0. and 1 is greater than equal to x is greater than equal to 0. Take union of both term, it become minus 1 to 1. In this question the correct answer is C, minus 1 to 1. In sixth question, find the domain of cos inverse x square minus 4. Suppose this term as y and the domain of cos inverse y is minus 1 to 1. Put the value of y, x square minus 4 is less than equal to 1. Add 4 both sides. X square is less than equal to plus 4. 3 less than equal to x square less than equal to 5. In next step, take square root. After taking square root, it become square root of 3 less than equal to x is less than equal to square root of 5, and minus square root of 3 is greater than equal to x is greater than equal to minus square root of 5. Now taking union of both term, it become square root of 3 square root of 5 union minus square root of 5 comma minus square root 3. So correct answer is option D. In seventh question, find domain of sine inverse x. Domain of sine inverse x is minus 1 to 1. So correct option is option B. In eighth question, find range of cos inverse x. Cos inverse x range is 0 to pi. So correct option is option D. Domain of sec inverse x. Domain of sec inverse x is all real number minus 1 to 1. So correct option is option A. Domain of cos inverse 2x minus 1. Same, suppose this term as y. Domain of cos inverse y is minus 1 that's equal to 1. Put the value of y, become 2x minus 1. Add 1 both side, become 0 less than equal to 2x less than equal to 2. Divide by 2, it become x to 1. So the domain of this function is 0 to 1. Correct answer is option A, 0 to 1. In 11th question, find the domain of the function sine inverse x plus cos inverse x. Domain of sine inverse x is minus 1 to 1, and domain of cos inverse x is also minus 1 to 1. So domain of overall function fx is the intersection of both domains. Intersection of both domains is also same. Correct answer is option A, minus 1 to 1. Find the principal value of sine inverse minus square root of 3 by 2. Basically, sine inverse minus x is equals to the minus sine inverse x. So this term can be write it as sine inverse minus square root of 3 by 2 is equals to the minus sine inverse root 3 by 2. And the value of sine inverse square root of 3 by 2 is pi by 3. So correct answer is option C, minus pi by 3. The value of cos inverse cos 7 pi by 6. Cos inverse cos 7 pi by 6. Basically, cos inverse cos x is equals to x when x belongs to 0 to pi. In this question, 7 pi by 6 is not belongs to 0 to pi. So we try to convert in the range of 0 to pi. 7 pi by 6 can be written as pi plus pi by 6. And cos pi plus theta is equals to the minus cos theta. So cos pi plus pi by 6 is equals to the minus cos pi by 6. And cos inverse minus x is equals to the pi minus cos inverse x. So according to formula, cos inverse minus cos pi by 6 can be written as pi minus cos inverse cos pi by 6. Pi by 6 is lying in the range of 0 to pi. So it will become pi minus pi by 6. After solving this, become 5 pi by 6. Therefore, correct answer is option C. In 14th question, cot cos inverse 7 by 25. There is some correction. In place of option D, write 7 by 24. Suppose cos inverse 7 by 25 is theta. Basically, we have to find the value of cot theta. Cos inverse 7 by 25 is equals to theta. This term can be written as cos theta is equals to the 7 by 25. Now let us draw a small right angle triangle. This angle is supposed as theta, and this is perpendicular, this is base, and this is hypotenuse. Cos theta is basically base upon hypotenuse. So base is 7, hypotenuse is 25. According to Pythagoras theorem, perpendicular is 24. Using this triangle, find the value of cot theta. Cot theta is equal to basically base upon perpendicular. So cot theta is 7 upon 24. Correct answer is option D. In 15th question, find the value of sine inverse cos 33 pi by 5. Sine inverse cos 33 pi by 5. 33 pi by 5 can be written as 6 pi plus 3 pi by 5. Basically, formula of cos 2 n pi plus theta is equals to the cos theta. Apply this formula in this portion. We get sine inverse cos 3 pi by 5. Now we try to convert cos in term of sine. Cos theta is equals to the sine pi by 2 minus theta. Use this formula in this portion. We get sine inverse sine pi by 2 minus 3 pi by 5. It becomes sine inverse sine minus pi by 10. Basically sine inverse sine minus pi by 10. Minus pi by 10 is lying between minus pi by 2 to pi by 2. So it becomes minus pi by 10. Therefore correct answer is option D. In 16 question, principal value. It is asking from principal value, basically range. Indirectly it is asking about range. So the range of cos inverse x function is 0 to pi. Correct answer is option C. In 17 question, principal value means it is asking about range. So the range of cos inverse x function is minus pi by 2 to plus pi by 2 plus pi by 2 plus 0. Correct option is option D. In 18 question, find the value of tan inverse tan 3 pi by 4. Tan inverse tan x is equals to x when x belongs to minus pi by 2 to pi by 2. Basically 3 pi by 4 is not lie in the range of minus pi by 2 to plus pi by 2. Now try to convert in the range of minus pi by 2 to plus pi by 2. Tan inverse tan 3 pi by 4 can be written as pi plus pi minus pi by 4, and tan pi minus theta is equals to minus tan theta. Basically tan pi minus theta is equal to the minus tan theta. So tan pi minus pi by 4 is minus tan pi by 4. Tan inverse minus x. Tan inverse, basically tan inverse minus x is equals to the minus tan inverse x. So by using this formula it will become tan inverse tan pi by 4 with negative sign. Now pi by 4 is lying in the range of minus pi by 2 to plus pi by 2. So it can be written as pi by 4 and with negative sign. Therefore the correct answer is option C, minus pi by 4. In 19 question, asking about principal value of cos inverse cos 2 pi by 3 plus sine inverse sine 2 pi by 3. So basically cos inverse cos x is equals to x when x is lie from 0 to pi. In this portion, cos inverse cos 2 pi by 3. 2 pi by 3 is lie in between 0 to pi. So cos inverse cos 2 pi by 3 is equals to the 2 pi by 3, and sine inverse sine x. Basically, sine inverse sine x is equals to x only when x belongs to minus pi by 2 to pi by 2. In this case, 2 pi by 3 is not lying in the range of minus pi by 2 to plus pi by 2. In this part, we try to convert into range of minus pi by 2 to plus pi by 2. Sine 2 pi by 3. 2 pi by 3 can be written as pi minus pi by 3, and sine pi minus theta is equals to the sine theta. So sine pi minus pi by 3 is equal to sine pi by 3. Basically, this term is equal to the sine pi by 3. Now pi by 3 is lying in the range of minus pi by 2 to plus pi by 2. This term can be written as pi by 3. Overall answer is 2 pi by 3 plus pi by 3. 2 pi by 3 plus pi by 3 is equals to the pi. Therefore, correct answer is option A. In 20th question, principal value of sine inverse sine 2 pi by 3. Same as 19th question. Basically, sine inverse sine pi by 3, 2 pi by 3, we get pi by 3. So correct answer of 20 question is option C, pi by 3. In this question, we have to find the value of tan in 1 by 2 cos inverse square root of pi by 3. Basically, formula of tan theta by 2 is equals to the square root of 1 minus cos theta upon 1 plus cos theta. This is the formula of tan theta by 2. Now, in this question, cos inverse square root of 5 by 3, suppose it as theta. Cos inverse square root of 5 upon 3 is equals to theta. We can write this term as cos theta is equals to square root of 5 upon 3. Now use this formula of tan theta by 2. Tan theta by 2 is equals to the square root of 1 minus cos theta. 1 minus cos theta value is square root of 5 upon 3 upon 1 plus square root of 5 upon 3. After solving this, it becomes 3 minus square root of 5 upon 3 plus the square root of 5. Now rationalize this term. After rationalize, it becomes 3 minus square root of 5 upon 3 plus square root of 5. After rationalize, it becomes square root of 3 minus square root of 5 square upon a square minus b square is 9 minus 5. We get 3 minus square root of 5 upon square root of 4 is become 2. So correct answer is option C. This question is same as previous question. Again, suppose this term as theta cos inverse 2 upon square root of 5 is equals to theta. It become cos theta is equals to the 2 by square root of 5. Using same formula, tan theta by 2 is equals to the square root of 1 minus 2 upon square root of 5 upon 1 plus 2 upon square root of 5. We get square root of 5 minus 2 upon square root of 5 plus 2. Again rationalize this term. Square root of 5 minus 2 upon square root of 5 plus 2 multiply root of 5 minus 2 upon root of 5 minus 2. It becomes square root of 5 minus 2 upon 1. Therefore, correct answer is option B. In this question, to find the value of sine, cot inverse, cos, tan inverse 1. Sine, cot inverse, cos, okay, tan inverse 1. Basically, tan inverse 1 is equals to the pi by 4. Put the value of tan inverse 1. It become sine cot inverse cot pi by 4. Cot pi by 4 value is cos pi by 4 value is 1 upon square root of 2. Sine cos inverse 1 upon square root of 2. Sorry, this is cot. Now we try to solve sine cot inverse 1 upon square root of 2. Again, suppose this term as any alpha, and we try to solve using triangle. This angle is alpha, and cot inverse 1 upon square root of 2 is equals to alpha. Cot alpha is equals to 1 upon square root of 2. Cot alpha basically base upon perpendicular. Base is 1, perpendicular is square root of. Using Pythagoras theorem, hypotenuse is 3. Basically in this part, you have to find sine alpha. Sine alpha is perpendicular upon hypotenuse. Perpendicular is square root of 2 and square root of 3. So final answer is square root 2 of 3. Therefore correct answer is option D. In this question, you have to find 2 sec inverse 2 plus sine inverse 1 upon 2. Basically, sec inverse 2 is equals to the pi by 3, and sine inverse 1 upon 2 is equals to the pi by 6. Now put the value of these two. 2 multiply pi by 3 plus pi by 6. 2 pi by 3 plus pi by 6 is equals to the LCM is 6. We get 4 pi plus pi. It become 5 pi by 6. This is the correct answer, option B. Find the value of sine pi by 3 minus sine inverse minus 1 by 2. Sine inverse minus x basically is equal to the minus sine inverse x. Sine pi by 3 minus sine inverse minus 1 by 2. By using this formula, it become sine pi by 3 minus minus sine inverse 1 by 2. Minus minus will become positive in next step, become sine pi by 3, and sine inverse 1 by 2 value is equals to the pi by 6. Minus minus will become positive, and sine inverse 1 by 2 is pi by 6. Pi by 3 plus pi by 6 is equals to the pi by 2, and the value of sine pi by 2 is 1. So correct answer is option A. In this question, to find the value of tan inverse 1 by 2 plus tan inverse 1 by 3. Basically, there is a formula of tan inverse x plus tan inverse y is equals to the tan inverse x plus y upon 1 minus x multiply y. Now using this formula in this question, here x is 1 by 2 and y is 1 by 3. This is x, this is y. By applying this formula, it becomes 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 multiply 1 by 3. Now take LCM. This is tan inverse. LCM is 6, become 3 plus 2. Also same, the LCM is also 6. 1 minus 6 minus 1. Cancel 6 and 6, become tan inverse 3 plus 2 is 5, and 6 minus 1 is also 5. Tan inverse 1. Basically the value of tan inverse 1 is pi by 4. So correct answer is option B. Option D, pi by 4. Cos inverse 1 by 2 plus 2 sine inverse 1 by 2. Basically sine inverse 1 by 2 is equals to the pi by 6, and cos inverse 1 by 2 is equals to the pi by 3. Put this value, we get pi by 3 plus 2 multiply pi by 6. This term is cancelled by 2, then it becomes pi by 3 plus pi by 3 is equals to 2 pi by 3. Therefore, correct answer is option D. In 28th question, using the same formula of tan inverse x plus tan inverse y. Suppose this term is x and this is y. Apply this formula. Get tan inverse 1 by 4 plus 2 by 9 upon 1 minus 1 by 4 multiply 2 by 9. Tan inverse. Now take LCM. LCM of 4 and 9 is 36. Now 9 plus 8. Here the LCM is also 36. 36 minus 2. 36 are cancel out. And 9 plus 8 is 17. Tan inverse 17 plus 34. 17 and 34. It's cancel out. It become tan inverse 1 by 2 because 17 multiplied 2 is equals to 34. So correct answer is option D. Okay, basically tan inverse x minus tan inverse y is equals to the tan inverse x minus y upon 1 plus xy. Now first I try to solve this term. In this term, tan inverse is x minus y. In denominator part, x plus y can be written as y plus x. Now we divide numerator and denominator by x by y. Then it becomes x upon y minus 1 upon 1 plus x upon y. In this part, we divide numerator and denominator by y. Now we compare this term by tan inverse x minus tan inverse y formula. X upon y can be written as 1 multiply x upon y. In this part, basically tan inverse x minus y, if we suppose it first term and this is second term, this is first term and second term minus and multiplication of first term and second term. After comparing this formula with formula, then this term can be written as tan inverse x upon y minus tan inverse 1. So basically this tan inverse, now we put the value of tan inverse x minus y upon y plus x is this. Tan inverse x upon y minus value of this term is this. Here is negative sign due to which the sign of tan inverse 1 is become positive. Tan inverse 1. This term is cancel out and the tan inverse 1 is equals to pi by 4. Therefore correct answer is option C. In this question there is some formula 2 tan inverse x. The value of this is tan inverse 2x upon 1 minus x square. Now but we are trying to use the formula. Basically 2 tan inverse 1 by 3 plus tan inverse 1 by 7. It becomes tan inverse 2 multiply 1 upon 3 upon 1 minus 1 upon 3 square plus tan inverse 1 upon 7. After solving, this term will become 2 upon 3 upon 9 minus 1, 8 by 9 plus tan inverse 1 upon 7. Basically, this 3 can be cancelled out by 9. So in next part, write it as tan inverse 2 by 3 multiply 8 by 9 plus tan inverse 1 upon 7. 2 4s are 8. 3 multiply 3 is 9. Become tan inverse 3 by 4 plus tan inverse 1 upon 7. Now applying same formula of tan inverse x plus tan inverse y, tan inverse 3 by 4 plus 1 by 7 upon 1 minus 3 by 4 multiply 1 by 7. After solving this, we get tan inverse 1, and tan inverse 1 is pi by 4. So correct answer is option D. In this question, sine inverse 3 by 5 plus tan inverse 1 by 7. Now we try to convert this sine inverse in term of tan inverse. Now suppose this term as angle theta. Sine inverse 3 by 5 is equals to theta, and the sine theta is equals to 3 by 5. Now draw a right angle triangle. This angle is supposed as theta, and sine theta is perpendicular upon hypotenuse. Perpendicular is 3 and hypotenuse is 5. By using Pythagoras theorem, base is 4. Now in term of tan, we find tan theta. Tan theta is basically perpendicular upon base. Perpendicular is 3 and base is 4. So theta is equal to tan inverse 3 upon 4. Now we get value of theta in term of tan inverse is 3 upon 4. Now again apply same formula, tan inverse x plus y. Tan inverse 3 upon 4 plus 1 upon 7 upon 1 minus 3 upon 4 multiply 1 upon 7. After solving this, it become tan inverse 1. Tan inverse 1 is pi by 4. Therefore correct answer is option A, pi by 4. In 32 question, the value of tan inverse 1 plus tan inverse 2 plus tan inverse 3. Apply same formula of tan inverse x plus y. First we apply formula in these two terms. We get tan inverse 2 plus 3 upon 1 minus 2 multiply 3. Tan inverse 1 plus tan inverse 2 plus 3 is 5 and 1 minus 6 is minus 5. 5 are cancelled out. It become tan inverse minus 1. Now apply the formula of tan inverse x plus tan inverse y again. Become 1 plus minus 1 upon 1 minus 1 multiply minus 1. It become tan inverse 0 upon 2. 0.2 means tan inverse 0. Now the value of tan inverse 0 is 0 pi 0 pi 2 pi. Here is the option is A and C. The correct option is C because tan inverse 1 is an angle, some angle alpha. This tan inverse 2 is also some angle beta and tan inverse 3 is also some angle gamma. The addition of all three angles cannot be 0. That's why we cannot put option A. So correct answer is option C. The value of tan in cos inverse 4 by 5 and tan inverse 2 by 5. Again, we try to convert cos inverse in terms of tan inverse. Let us suppose this term as theta. So cos inverse 4 upon 5 is equals to theta and cos theta is equals to 4 upon 5. Again we draw a right angle triangle. Suppose this angle is theta. Cos theta is basically base upon hypotenuse. Base is 4 and hypotenuse is 5. Using Pythagoras theorem it become 3. Tan theta is basically perpendicular upon base. Perpendicular is 3 and base is 4. So theta is equals to tan inverse 3 upon 4. First we try to find tan inverse 3 upon 4 plus tan inverse 2 by 3. Basically it becomes tan inverse A plus B. A plus B upon 1 minus A into B. Now take LCM. It becomes tan inverse 9 plus 8 17 upon 6. It becomes 17 upon 6. So this whole term is equals to tan inverse 17 upon 6. So in tan inverse 17 upon 6 is equals to the 17 upon 6. Therefore correct answer is option C. In this question here is also again 2 tan inverse 1 upon 5. Using the formula of 2 tan inverse x. Basically the formula of 2 tan inverse x is tan inverse 2x upon 1 minus x square. Therefore 2 tan inverse upon 5 is equal to the, applying the same formula, we get tan inverse 2 multiply 1 by 5 upon 1 minus 1 by 5 square. Tan inverse 2 by 5 upon 24 by 5. 24 by 25. We can write it as 2 by 5 multiply 25 by 24. This is cancelled out by 5 and this cancelled out by 12. It becomes tan inverse 5 upon 12. Now put the value of 2 tan inverse 1 by 5. Tan inverse 5 by 12 minus 5 by 4. Now here we use again a new formula of tan a minus b. Basically formula of tan a minus b is equal to the tan a minus tan b. I write the formula here, tan a minus tan minus b is equal to the tan a minus tan b upon 1 plus tan a tan b. Now apply the same formula. This term is become a and this term is b. Tan into tan inverse tan inverse 5 by 12 is 5 upon 12 and tan pi by 4 value is 1. 1 minus 5 by 12 multiply 1. It become minus 7 upon 12 minus 5 is 7. 7 is cancelled out, minus 1. It become minus 1. Here is some mistake. Oh, here is plus sign. So according to plus sign, it become 17. Correct answer is minus 7 upon 17. Correct answer is option D. In this question, cos inverse alpha plus cos inverse beta plus cos inverse gamma is equals to 3 pi. Basically, domain of cos inverse function is minus 1 to 1 and the range of this function is 0 to pi. Is a close bracket. Range of the function is 0 to pi. It means the maximum value of this function is cos inverse is pi. Maximum value. This is also pi. This is also pi. So it become 3 pi. So we suppose it as cos inverse alpha is equal to pi is equal to the cos inverse beta is equals to the cos inverse gamma. Therefore cos pi is equals to the alpha is equals to beta is equals to gamma is equals to minus 1. Now put the value of alpha, beta, gamma in this term. Alpha multiply beta plus gamma plus beta multiply alpha plus gamma plus gamma multiply alpha plus beta. Now after putting the value of alpha, beta, gamma, it become 2 plus 2 plus 2 is equals to 6. Therefore correct answer is option D, 6. In this question, is the sec square. Basically, this question can be written as tan inverse 2 and this whole square. Now we try to convert tan inverse in term of sec inverse. Again we draw a triangle. Suppose tan inverse 2 as theta. Tan inverse 2 is equals to theta and tan theta is become equal to 2. Draw a right angle triangle. Here this angle is theta. Basically tan theta is perpendicular upon base. Perpendicular is 2 and base is 1, and according to Pythagoras theorem hypotenuse is square root of 5. Basically this question is sec theta whole square. Sec theta is hypotenuse upon base. Hypotenuse is square root of 5 and this is 1. Put the value of sec theta in this question at 5. 5 is the correct answer. So correct option is C. In this question, sine inverse 1 by 2 plus cos inverse x is equal to 1. Basically, as we know, sine pi by 2 is equals to 1. So I can write this whole term is equals to pi by 2 because sine pi by 2 is equals to 1. And also there is another formula of sine inverse x plus cos inverse x is equals to pi by 2. Here in this term, sine inverse 1 by 5 plus cos inverse 1 cos inverse x is equals to pi by 2. After comparing this term with formula these two terms are equal. Here by comparing cos inverse x and sin inverse x, the value of x is equals to 1 upon 5. Therefore correct answer is option D. In this question, sin inverse x upon 5 plus cos x inverse 5 by 4 is equal to pi by 2. Now we use the same formula. Basically, sin inverse x plus cos inverse x is equals to pi by 2. Now I am trying to convert this term in term of cos inverse. Cosec inverse 5 by 4. Now we suppose this term as theta, and cosec theta is equals to 5 upon 4. Draw a right angle triangle. Suppose this angle theta, and cosec theta is basically hypotenuse upon perpendicular. Using Pythagoras theorem it become 3. Basically cos theta is base upon hypotenuse. Base is 3 and hypotenuse is 5. So the theta is equals to the cos inverse 3 upon 5. Now we use this value in place of cosec inverse. So sine inverse x upon 5 plus cos inverse 3 upon 5 is equals to pi by 2. Again we equate these two terms according to formula. These two terms are equal. So x upon 5 is equals to the 3 upon 5. 5 are cancel out. So correct answer is x is equals to 3. Therefore option is D. Again in this question we have to find the value of x. We are applying the same formula of tan inverse A plus tan inverse B. So tan inverse 1 plus x plus 1 minus x upon 1 minus 1 plus x multiply 1 minus x is equals to pi by 2. This x and this x are cancel out. Numerator is 1 plus 1 2 upon 1 minus, here is 1 plus x and 1 minus x become 1 square minus x square. Because of negative sign this term is become positive, is equals to pi by 2. It become tan inverse 1 and 1 are cancel out. Tan inverse 2 upon x square is equals to pi by 2. 2 upon x square is equal to 10 pi by 2. 10 pi by 2 is basically not defined, or you can say infinity. It means the value of x is equals to 0. If we put the value of x is equal to 0, then 2 upon 0 will become infinity. So the correct answer is option C, x is equals to 0. Sine cot inverse x. Again we take cot inverse x at theta. Cot inverse x is taken as theta and cot theta is equals to x. Basically we have to find the value of sine cot inverse x. Cot inverse x is taken as theta, so we have to find the value of sine theta. Again we draw a triangle. This angle supposes theta. Cot theta is basically base upon perpendicular. Base is x and perpendicular is 1. According to Pythagoras theorem, hypotenuse will become 1 plus x square. Sine theta is perpendicular upon hypotenuse. Perpendicular is 1 and hypotenuse is 1 plus x square. So the value of sine theta is 1 upon under root 1 plus x square. So correct answer is option B. Same question. Again we take this term as theta. Cos inverse x is equal to theta and cos theta is equals to x. Tan cos inverse x, and cos inverse x is term taken as theta, so we have to find the value of tan theta only. Again we draw a right angle triangle. This angle is taken as theta and cos theta is base upon hypotenuse. By using Pythagoras theorem, perpendicular is 1 minus x square. So the value of tan theta is perpendicular upon base. Perpendicular is 1 minus x square of square root upon x. So the correct answer is option A. In this question, You have to find the value of x. Again, using this formula, sine inverse x plus cos inverse x is equals to pi by 2. Basically, we find the value of cos inverse x is equals to pi by 2 minus sine inverse x. Use this formula in place of cos inverse x. Now we get sine inverse x plus sine inverse 1 minus x is equals to pi by 2 minus sine inverse x. Now from RHS side of sine inverse term, move to the LHS side. It will become positive, and from LHS sine inverse 1 by x term will become negative. Sine inverse x plus sine inverse x become 2 sine inverse x is equals to pi by 2 minus sine inverse 1 minus x. Now again take the term to the LHS side. It become positive pi by 2 minus 2 sine inverse x. Take the sine to the RHS side. Sine pi by 2 minus 2 sine inverse x. Basically sine pi minus theta formula is sine pi by 2 minus theta is cos theta. Sine pi by 2 minus theta is cos theta. Basically this theta is this. So by using this formula it become, now I write down his here, 1 minus x is equals to the sine pi by 2 minus theta will become cos 2 sine inverse x. Basically here we use cos 2 theta formula. Cos 2 theta formula in term of sine. Cos 2 theta formula in term of sine is 1 minus 2 sine square in bracket sine inverse x. 1 minus x is equals to the 1 minus 2 sine square bracket sine inverse x is x square. 1 1 are cancel out. Here 2x square minus x is equals to 0. Now take common from x, become 2x minus 1 is equals to 0, and the value of x is 0 and 1 upon 2. Here is 2 value of x. So correct answer is option C. Before starting this question, I'm telling you an important formula. 1 minus sin x is equals to the cos x by 2 minus sin x by 2 whole square, and square root of 1 minus Sin x is equals to the cos x by 2 minus sin x by 2. This formula is modified when we use plus sign is here, then only signs are changed. Write down this formula. Now I put this formula in this question. Cot inverse square root of 1 minus sin x is cos x by 2 minus sin x by 2 plus square root of 1 plus sin x formula is cos x by 2 plus sin x by 2. Square root of 1 minus sin x formula is cos x by 2 minus sin x by 2. Square root of 1 plus sin x formula is same cos x by 2 plus sin x by 2, but due to negative sign, the sign of cos and sin both will change. Now sin x by 2 and sin x by 2 are cancel out. Here cos x by 2 and cos x by 2 are cancel out. It become cot inverse 2 cos x by 2 upon minus 2 sin x by 2. 2 and 2 are cancel out. Become cot inverse cos upon my sin is cot, negative of cot x by 2. Basically here again is new formula, cot inverse minus x is equals to the pi minus cot inverse x. So we apply this formula in this term, we get pi minus cot inverse cot x by 2. The final answer is pi minus, after solving this we get x by 2. So pi minus x by 2. Therefore correct answer is option A. Sine square cos inverse 1 by 2. As we know, sine square theta is equals to 1 minus cos square theta, and also cos square theta is equals to 1 minus sine square theta. Now in this question we convert sine in term of cos and cos in term of sine. Why we are converting sine in term of cos and cos in term of sine? Because inside the sine here is cos. That's why we convert sine in term of cos, and also sine is here. So we are trying to convert cos in term of sine. So sine square cos inverse 1 upon 2 is equals to the 1 minus cos square cos inverse 1 upon 2. Now we solve this term, it become 1 minus cos inverse 1 by 2. We write as is whole square. 1 minus cos inverse 1 by 2 is 1 by 2, and square of 1 by 2 will become 1 by 4. 1 minus 1 by 4 is 3 by 4. Again we convert this cos in term of sine. Cos square in bracket sine inverse 1 by 2 is equals to the 1 minus sine square bracket sine inverse 1 by 2. It become 1 minus basically sine inverse 1 by 2 can be written at square 1 minus sine inverse 1 by 2 is 1 by 2 square. Again 1 minus 1 by 4 is equals to 3 by 4. Oh, sorry, here is 1 by 3. By mistake I put 1 by 2. 1 by 3. 1 by 3 square means 1 by 9. 1 minus 1 by 9 is 8 by 9. Now we add 3 by 4 and 8 by 9. Simply add 3 by 4 plus 8 by 9. It becomes 59 by 36. So the correct answer is option B. In this question, cot inverse minus 1 by 5 is equals to theta. Basically, the range of cot inverse x is cot inverse x is 0 to pi. It means the value of theta is lying between 0 to pi. The value of theta is lying between 0 to pi. So the cot inverse minus 1 by 5 is equals to theta. Can we write it as cot theta is equals to minus 1 upon 5. Basically cot theta is negative and we have to find the value of sine theta. Means sine theta is lying in the 0 to pi, means in first and second quadrant. And in first and second quadrant sine theta is always positive. It means the value of sine theta is positive. Okay, we try to solve this question again using the formula 1 plus cot square theta is equals to cosec square theta. 1 plus cot square theta is equal to cosec square theta. We convert cosec square theta is equal to 1 upon sine square theta. It means it becomes sine square theta is equals to 1 upon 1 plus cot square theta. By putting the value of cot theta, we get sine theta value is sine theta is we after solving this 1 upon 5 1 upon 25 and 26 and become 5 upon square root of 26. So correct answer is option A. Two angles of a triangle are cot inverse 2 and cot inverse 3. Find the third angle. Basically the sum of the angle of triangle are 180 degree. Let us to suppose third angle is x. uh, so the sum of the angle of triangles are cot inverse 2 plus cot inverse 3 is equals to 180 degree means pi. X plus cot inverse 2 can be written as tan inverse 1 upon 2 because cot inverse x is equal to tan inverse 1 upon x. Because cot inverse cot inverse x is equals to tan inverse 1 upon x. Also cot inverse 3 can be written as tan inverse 1 upon 3 is equals to pi. X plus tan inverse 1 by 2 plus tan inverse 1 by 3. Again we use the formula of tan inverse x plus tan inverse y. Tan inverse 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 multiply 1 by 3 is equals to pi. Tan inverse, it become 5 upon minus 5 is equals to pi minus x. We take x from LHS to RHS. 5 5 are cancelled out, it become tan inverse minus 1 is equals to pi minus x. And tan inverse minus 1 is minus pi by 4, become minus pi by 4 is equals to pi minus x. I think there is some mistake. 3 plus 2 5 is 6. Here is plus 5, not minus 5. By mistake here is, so it become tan inverse 1 is pi by 4. Value of x is pi minus pi by 4. After taking LCM it become 3 pi by 4. Therefore correct answer is option B. In this question, x plus 1 upon x is 2. Then the principal value of sine inverse x. X plus 1 upon x is equals to 2. Basically in this question, if this value is 1 and this value is 1, then it become 2. So finally the value of x is 1 and the value of sine inverse 1 is pi by 2. Correct answer is option B. In this question we have to find the value of y. Tan x plus y is 33 and value of x is equals to the tan inverse 3. We, value of tan x is equals to 3. Now I apply the formula of tan x plus tan y. Value of tan x plus tan y formula is tan x plus tan y upon 1 minus tan x tan y is equals to 33. Tan x value is 3 plus tan y upon 1 minus 3 tan y is equals to 33. Now cross multiply these two terms. After cross multiply we get 3 plus tan y is equals to 33 minus 99 tan y. Take minus 99 tan y to LHS, it become 100 tan y and 33 minus 3 is 30. So the value of tan y is 30 upon 100. 30 upon 100 is 0.3. By taking 10 to RHS, it become y is equal to tan inverse 0.3. So in this question, here is some mistake. It become tan inverse 0.3. Please correct this. The correct answer is option B. In this question, the value of tan inverse tan 5 pi by 6 and cos inverse cos 13 pi by 6. Okay, basically tan inverse tan x is equal to x only when x is belongs to minus pi by 2 to plus pi by 2. But this term is lying in the range of minus pi by 2 to plus pi by 2. Basically tan inverse tan x is equals to x when x belongs to minus pi by 2 to plus pi by 2. But 5 pi by 6 is not lying in the range of minus pi by 2 to plus pi by 2. So 5 pi by 6 can be write it as pi minus pi by 6. And type 10 pi minus theta is minus tan theta. It becomes tan inverse minus 10 pi by 6. Negative sign is here because 10 pi minus pi by 6 is minus 10 pi by 6, and it will become minus 10 10 pi by 6. Pi by 6 is lying in the range of minus pi by 2 to plus pi by 2. So it become minus pi by 6. The value of this term is minus pi by 6. Now we solve another term, cos inverse cos 13 pi by 6. Here also is the same condition. Cos inverse cos x is equal to x only when x belongs to 0 to pi. Here is a close bracket. But 13 pi by 6 is not lying in the range of 0 to pi. So we try to convert in the range of 0 to pi. So 13 pi by 6 can be write it as 2 pi minus pi by 6. And cos 2 pi minus pi by 6 is cos pi by 6, because cos 2 pi minus theta is equal to cos theta. So after solving this, it will become pi by 6, because now pi by 6 is lying in the range of 0 to pi. So we write it as pi by 6. Now after adding this, minus pi by 6 and plus pi by 6 is 0, because both are opposite sign. So they are cancel out. So the correct answer is option A, because minus pi by 6 and plus pi by 6 are cancel out. Therefore the correct answer is option A. In this question, the range of x is given is pi to 3 pi by 2. It means our x is lying in the third quadrant, and in third quadrant 10 is positive. It means only tan x is positive. Basically in this question we use a new formula again. 1 plus cos x is 2 cos square x upon 2, and 1 minus cos x is 2 sine square x upon 2. Now put this value in the question. Become tan inverse square root of 1 plus x square root of 2 cos square x upon 2 plus square root of 2 sine square x upon 2 upon square root of 2 cos square x upon 2 plus square root of 2. Here is negative sign, by mistake I use positive, is negative 2 sine square x upon 2. Basically, after solving square root, it becomes cos x upon 2 plus square root of 2 sine x upon 2 upon square root of 2 cos x upon 2 minus square root of 2 sine x upon 2. Basically, our x is lying in the third quadrant. Here the angle is x by 2. Now we have to check where is x by 2 lie. Basically, pi is less than equal to x 3 pi by 2. If you divide by 2 both sides, it becomes pi by 2 is greater than x by 2 is less than 3 pi by 4. Now our x by 2 is lying in the second quadrant because x by 2 is greater than pi by 2 and less than 3 pi by 4. It lies in the second quadrant. Only sine theta is positive. Basically, in second quadrant, only sine x by 2 is positive and cos x by 2 is negative. And cos x by 2 is negative. Cos x by 2 is negative. To make this cos x by 2 positive, we use negative sign here. Now we solve this question by erasing this formula part. It becomes tan inverse. Now take square root 2 of common from numerator side. It becomes cos x by 2 minus square root of 2. Here also we take minus square root 2 common, become cos x by 2 plus sine x by 2. Minus square root of minus square root 2 are cancel out. Now we solve this question here. Now in the next step, we divide numerator and denominator by cos x by 2. It become tan inverse 1 minus tan x by 2 upon 1 plus tan x by 2. Basically 1 minus tan x by 2 and 1 plus tan x by 2 is equals to the tan pi by 4 minus x by 2. Basically 1 minus 1 minus tan x by 2 upon 1 plus tan x by 2 is equals to the tan pi by 4 minus x by 2. Put this formula in this equation. We get tan in bracket tan inverse in bracket tan pi by 4 minus x by 2. 10 and 10 inverse cancel out. Final answer is pi by 4 minus x by 2. So the correct answer is option A. I hope you like my video. Thank you for watching my video.